Today we're going to talk about discrete probability distribution. So you need to understand that all random variables have a corresponding probability distribution, which describes the probability that the variable will take a certain value. So below we have, if x is a random variable with possible values x of 1, x of 2, x of 3, all the way to x of n, and the corresponding probabilities p sub 1, p sub 2, p sub 3 to p sub n, such that the probability that x will equal a certain possible value is going to be equal to the probability of that value taking place. And we have the subscripts I. I can take on any number from 1 to n. You need to understand that when we are talking about probability, that probability can only be in between 0 and 1, because probability can only go from 0% to 100%. You also need to understand that the sum of your probabilities of your random variables should be equal to 1. When you add up all of your probabilities, you should get 1. And then you also need to understand that whenever we talk about p sub 1 all the way to p sub n, we are looking at the distribution, okay, of the probabilities of the random variables. So example 1, we're going to look at x being the number of tails obtained when flipping 2 coins. So we already know that if we're flipping 2 coins, we have 4 sides total. Coin 1 has 2 sides. Coin 2 has also 2 sides. So we have 4 sides total. So whenever you're flipping a coin, x can either be and take on the values of no tails being flipped, 1 tail being flipped, or you can get 2 tails when you flip both of the coins. So these are my random variables, okay? Or these are the possible values, excuse me. Okay? So 0, 1, and 2 are the possible values that x could take on if I flip the coin, as far as the number of tails that I can get. So now if we look at the probability, okay, when we look at the probability of x being a certain number, we know that our probabilities of x will end up being that, let's say if I have no tails, I can only flip my coins one way and get no tails. So that's 1 out of 4. If I want to get 1 tail, I can either flip 1 coin and get 1 tail. So it could either be coin 1 gives me the tail or coin 2 gives me the tail. So that's going to be 2 ways out of 4 to get 1 tail. And then, of course, to land on both of them on tails, there's only going to be 1 flip that can do that. I can do that in 1 flip. So that's going to be 1 out of 4. So as you can see here, these are the random variables, the values that it can take on, or the possible values, and then their corresponding probabilities. Now, if we look, remember, your probabilities have to add to equal 1. Okay, your probabilities have to add to give you 1. So if I were to add these, or take the sum using the sum symbol, so I can say the sum of my probabilities, my sum does equal 1 here, because 1 over 4 plus 2 over 4 plus 1 over 4 is 4 over 4, which is equal to 1. So I know that this checks out. So you can also display this as a table, or you can display it as a graph. So if we were to display it as a table, we would have a table that looks sort of like this. And we will have here that x is our random variable. And then we're going to have that the probability of x is going to take on a certain number here. So we have 3 values that x could be, 0, 1, 2. And then we also have the different probabilities. So we have 1/4, 2/4, or if you want to put 1/2, you can. So we have 2/4 or 1/2, and then you have another 1/4. Okay, so you can display it in the form of a table, Or if you want to, you can display it as a graph. So let's say we have a graph. We want to create our axis. So we know that the y value is going to be the probability. And then the x values is going to be, of course, the possible values, because x represents the possible values. So you can either have 0 tails, 1 tail, or you can have 2 tails. In your probability, we can have 1/4, 2/4, and then we can have, of course, you can go up to 3/4 if you want, even though it's really not needed. So what you're going to do is you can either do your graph and you can use bars. So if you were to use bars, the probability of having 0, the bar would go up to the 1/4 and then it will come back down. If we have the probability of only getting 1 tail, we would go up to the 2/4, because that's the probability, 2 out of 4 or 1/2. And draw a bar, and then the same thing for 2. It's going to be the probability of 1/4. So that's how you can graph it. Now, if you don't want to graph the bars, you can also graph vertical lines with points. So 0, if you get no tails, you could draw a little line with a dot up to the 1/4. You could do the same thing for 1. You could draw the line up to 2/4 or 1/2, and then the same thing for 2. Draw your line and goes up to the 1/4. So you can either do the bar or the lines with the points with the probability if you want. It does not matter. All right. So when we say x is a uniform discrete variable, that means that the values, the possible values, are going to have the same probability of occurring. Okay, so remember, when we think about the word uniform, we know when people wear uniforms on their job or at school, the purpose of it is to make everybody look the same. All right, so uniform discrete random variables will have the same probability of occurring when it comes to all the possible values or producing those possible values. The most frequently occurring value of a discrete probability distribution, of course, is going to be called the mode, because it's the most occurring. And then we have what we call the median. The median of the probability distribution is going to correspond to the 50th percentile. Okay? When the possible values are put in order, the median is going to be the value that causes the cumulative sum to reach 0.5. So let's look at example number 2. Example number 2 states that a game app recorded the number of boosts purchased by its subscribers in 1 month. 27% purchased 1 game boost, 39% purchased 2 game boosts, 18% purchased 3, 12% purchased 4, and 4% purchased 5. Let X be the number of boosts sold to a randomly selected subscriber. So part A tells us to state the possible values of X. So if X represents the number of boosts sold to a randomly selected subscriber, we can either have 1, 2, 3, 4, or 5 boosts. So those are my possible values of X. So X can be the numbers 1 through 5. All right. B, make a probability table for X. So if we want to make a probability table for X, all we have to do is look at our possible values as our X and our probabilities as our Y. So the probability that people will buy 1 boost was 27%, so that's 0.27. 2 boosts is 39%. And I'm writing them in decimal form. 3 is going to be 18%. 4 is 12%. and 5 is 4%. So that is my probability table. So next they want us to graph the probability distribution. So I'm going to make my axis, and I know my y-axis is my probability. I'm going to make my x-axis, which is all the possible values. So we have 1 boost, 2, 3, 4, 5. So we have 5 boosts here. Okay, 5 boost. So our probabilities, we are ranging all the way from 0.4 to 0.39. So I'm going to go by tenths. So when we do that, I am going to go by tenths. So that's 0.1, 0.2, 0.3, 0.4. Okay, so the probability that they buy 1 boost is going to be 0.27. So I just estimate it's going to be a little bit above half. Then we have 0.39, which is almost 0.4. For 2. 3 is 0.18. And excuse me, let me correct this here. 0.27 for 1 should be here. Sorry. 0.18 for 3 boosts is going to be here. And then we have 0.12 for 4 boosts, which is about here. And then we have 0.04, which is a little bit below half. So that'll be about right here. If you have graph paper, it'll be more accurate, but you all get the drift. All right, so if you wanted to do the bars, that's fine. If you wanted to do the lines with the points, you could have done that as well. It does not matter. Remember, it does not matter. All right. Now, part D is asking us to find the mode and the median of X. So remember, the mode is the most occurring value. So basically, my mode is going to be 2 boosts because majority of the people purchase 2 boosts, 39% of them. So here I can say my mode is equal to 2 boosts. Now the median. So remember, the median is the value of the probabilities, such that when you add up the probabilities from least to greatest, the probabilities from 1 magazine, 2 magazines, 3 magazines, if you put the probabilities in order, is going to be the cumulative sum. So the probability that you are going to, and when I say in order, I'm talking about adding up the probabilities in order of the number of boosts. Okay, so my number of boosts are already in order. So technically my probabilities correspond to those. So the order that they are currently in is fine. We know when we normally find the median, we normally line up the numbers from least to greatest and then find the number in the middle. But we are talking about probabilities. So we're taking the probability of the first possible value, then adding it to the probability of the second possible value, so on and so forth until we get to 0.5. So I'm saying this to clear up any confusion that you have to take the probabilities and line them up from least to greatest. No, you have to take the possible values and line them up from least to greatest, and then you add those corresponding probabilities. Okay, so we're going to start with 27%. So we say 0.27. We already know that's not 0.5. So if we add 0.39, we end up getting 0.66. And as you can see, 0.66 is greater than 0.5. So we can stop there. And you would just have to understand that this is the probability of getting one boost, the probability of getting two boosts. So it is the value that pushes you to equal 0.5 or more. So because I added my P2, my median is going to be 2 boost. Okay? So just remember that in order to find the median, you are adding up the probabilities until you see that the cumulative or the sum of those probabilities is 0.5 or greater, and whatever was the whatever value of X that had the probability that caused your sum to be 0.5 or greater, that is the median. All right. So we can also describe the probability distribution of a discrete random variable by using a mass function for the probability. And what that says is that the probability of something happening is equal to the probability that the random variable is equal to a particular value. So we need to make sure we understand that the domain is going to be the set of possible values of the variable, and the range is going to be the set of values that are in the probability distribution. So in other words, the domain is going to be the set of possible values that that variable can take on, and then the range is going to be the probability of each value happening. Okay, so let's look at it. Number 3. Example 3 says that we need to show that P of X, which is equal to 3x squared minus 2 divided by 82, when X is 1, 2, 3, or 4, is a valid probability mass function. So there are 2 conditions in order to be a valid probability mass function. And there are 2 conditions in order for you to be valid. The first condition is that your probability must be between 0 and 1. Okay? The probability of each individual random variable should be between 0 and 1. The second probability is that we take the sum of those individual probabilities. The sum of them should equal to 1. All right, so those are our 2 conditions. So all we have to do to figure out if this is valid or not is to make sure that both conditions are true. So let's do it. So the probability when X is 1, all we do is substitute in 1 for X. So that's going to be 3 times 1 squared minus 2 divided by 82. We know that we end up getting 1 over 82. If we find P of 2, we're going to do the same thing, except we're going to replace X with 2. And we end up getting 10 over 82. If we do P of 3, we're going to have 3 times 3 squared, which is 9. That's 27. 27 minus 2 is 25 over 82. Last but not least, we have the probability that 4 will occur. So if we do 3 times 4 squared, that's 3 times 16. And 3 times 16 is 48, and 48 subtract 2 is 46. So we end up getting 46 over 82. So as we can see here, condition number 1 is met. Okay, condition number 1 is met. All of my probabilities are between 0 and 1. And then if I add up all of my probabilities, I should get 1. So if I do 1 plus 10, that's 11, plus 25, plus 46, and I would get 82 over 82. So yes, this is a valid probability mass function. Okay, so it is valid. So that is it for today. If you have any questions, please let me know, and I will be happy to assist you. Have a good one.